This video will go over how to find the domain of radical functions. So I would go ahead and pause the video and go ahead and copy into your notes and then push play when you are ready. Alright, so let's go ahead and start. It says to find the domain. So remember, domain, all that means is what can you plug in for x? What values can you plug in for x? And it will still make the function a real number. So if we take a look at our first example here, f of x equals the square root of 2x minus 4. So using what we know from previous math classes about this symbol right here, we know that if we had a 4 inside the radical, that what times itself is 4 would have an answer of 2. But if we had a negative number inside the radical, then the square root of negative 16, there is no number. So we have to figure out what numbers, if x, we let x be, would make this negative, because we don't want that. So in other words, since this index, and remember the index is the little number right here, which if there isn't one, it's 2, which that's an even number. So even numbers are 2, 4, 6, 8, 10, etc. If we have an index of that value, you take whatever's inside the radical and tell yourself it has to be a big number, or else you're going to have a negative inside, bigger than or equal to 0, because 0 is not negative. That's why this line's here, because 0 could be in the radical. So then we're going to go ahead and solve this. Remember, if you divide by a negative, you flip the sign when you work with inequalities. So we're going to go ahead and add 4 to both sides. And we're dividing by 2, so we don't need to flip this sign. Okay, so it says to find the domain. It doesn't say in the directions how to. So one way we can leave our domain is in set builder notation. So x such that x has to be greater than or equal to 2. So we can write that here. Or in interval notation, if I draw a little picture, this is saying that x has to be greater than or equal to 2. So remember, we use the bracket when it has the line underneath. So we could also write our answer 2 with a bracket, infinity, because it could be any number over here. So in my own words, the numbers we're allowed to plug in for x is any number that is 2 or greater. So if we use a graphing calculator just to verify, and we see that, so if I go ahead and use, let me see if I can get you to see that here. So if we go ahead and use Desmos.com, and I went and graphed it, you can see that the graph starts here at 2, and then it keeps going infinitely on and on and on the right side. So it matches our graph. The algebra we got matches what the function's graph looks like. So now f of 10, we've seen this before in this class. This is just saying take function f, and it's saying plug in 10 for the x value. So then we'd have 20 minus 4, and then we'd have the square root of 16, which is 4. So our answer is 4. So if we go back to our graph, if I go to 10, here is 10, and you could see it has a point over here on the graph. Now, it's asking us next to find f of 0. So if x was 0, so here's 0, do you see how there's no graph here? So when we plug in 0, we're going to get not a real number, because there is no number, there is no point over here. So now we're going to go ahead and plug in 0 just to show it algebraically, but we know it should be not a real number. 0 does not work. So 2 times 0 is 0, 0 minus 4. We would get the square root of negative 4, which we can't right now. So it's called not a real number. Now later on in this class, we will learn about imaginary numbers and how to work with the complex number system. And at the end of this class, this equals 2i, in case you've seen that before or you're retaking this class. But for right now, we're not going to put 2i, and if you're confused by that, don't worry, because we haven't learned it, because the directions don't say that we're working in the complex number system. Okay, so if we look at this example over here, okay, if I asked you to find the domain of this equation over here, remember domain is what can x be? Well, over here, this x value is just being multiplied by this 6. So this one can be any number. Any number can go into x here, because it's just a multiplication. This 2 is just being multiplied, so it has no effect. So when you have a more complicated looking equation, if it has this radical symbol, and this is even, then you take whatever's inside the radical. Who cares? Ignore this. Ignore this. You take whatever's inside the radical and always set it greater than or equal to 0, because 0 is the smallest number that can go inside this radical here. So we have to figure out what numbers can go in for x, so it makes it a number 0 or greater. That's why we solve it this way. So every problem that has an even index, you're going to do it this way. Now if we take a look at our next example, the index here is odd. So since it's odd, the domain can be all real numbers. So we can write our answer like this. All real numbers, that's in interval notation. Or we can write it as x such that x is any real number. Now I also shared with you, because some teachers in the future might use this symbol, you could also write it as x such that x is an element, so that looks like an E, fancy E, put 2 vertical lines and then wrap it around and make an R. So all 3 of these are different ways to say x can be any number. Okay, so if the directions don't tell you how to leave your answer, you can use whichever of these formats you want. Now if we go to our graphing calculator and we graph this, okay, so we can see there's the graph, and we said all real numbers. So if you could see over here, it's going infinitely on the left and infinitely on and on the right. So whenever the index is odd, like 3, it's going to go left to right infinitely, the graph. So that means no matter what we plug in for x, it's going to work. So whenever you're doing a problem, so for example this one here, the index is a 3, so since it's odd, no work required, you would just show me, hey, it's odd, and the domain is all real numbers. Any number can plug in for x here, and any number can be squared and multiplied by 9. So you always have to look at each equation and look where the x is and what's allowed. So if we just do a quick little review of domain here, in the class before this you had linear equations, equations that when you graph it made lines. So if we take a look at where x is just being multiplied by 2 and then added by 5. You can plug in any number for x here. So if we look at the graph for that one, it goes infinitely left and infinitely right. It keeps going left, keeps going right. And we know that without looking at a graph, just by thinking about the relationship of the numbers with x here. So now if we take a look at example 2. So in chapter 6 we had equations with exponents. So the x value here would have to be squared. Well, any number can be squared. Negatives, positives, zeros, radicals, anything. And then we can multiply any number by 3 and add any number by 4. So this one also is all real numbers. So if we take a look at the graph for this one, you could see on the left side it keeps going and going and going. And then as we go to the right, it keeps going and going and going as well. So the domain is from the left to the right. It's going infinitely both ways. But we would know that just by looking at the equation. Okay. Then in chapter 7 in our class we talked about fractions, equations with fractions. Well, From previous math classes, you have learned that you can have 0 at the top of a fraction and any number down below in the denominator, but you can't have 0 in the denominator. You could have whatever number, any number here, on the top of your fraction, but the bottom of the fraction cannot be 0. So you take whatever's at the bottom of the fraction and say it can't be 0. And then you solve it and you get the bad number, which is 4. So if x was 4, you would get 0 down here. So it could be any number but 4. So if we take a look at the graph of this one. Okay. So as you could see, it's going infinitely, so it could be any number, and then it's getting closer and closer. Here's 5 right here. It's getting closer and closer and closer to 4, but it will never touch it. It gets very, I'm trying to get you to see that, gets very, very close here to 4, but never actually touches it. Same thing on this side. So here's 5. It keeps going and getting closer and closer to 4, but will never touch it. So again, that's just a little overview of domain. You have to think every equation you're given or function, where's x, what is it doing in the problem, and think about the what you've learned in math so far about fractions and radicals and so on. Okay, so if we want to continue with this problem here from our notes, we know that both of these should work because our domain is all real numbers. So I'm going to go ahead and plug in now. It says, this is saying, plug in -16 in for the function for x. So we plug in the -16, and we get cube root of 30, or -32 plus 5, which is -27. So what times itself 3 times is -27? And that would be -3, because -3 times -3 times -3 would make -27. So it is okay to have a negative inside when this is odd, because 3 numbers can multiply to make a negative. Okay, then the next problem is asking us to plug in 3/2 for the x value for the function. Okay, and then we have 2 times 3/2, and we know our rules for multiplying fractions that this is going to make 1 here. So we're just left with 3 plus 5, and we get the cube root of 8. And that means what times itself 3 times is 8? And that would be 2. Okay, so in the next section, we're going to go ahead and talk about graphing. And when you graph, you need to think about the domain, because you have to figure out what numbers you can plug into your table in order to graph radicals. So in the next problem you're going to be doing, it's going to ask you to graph. And you're going to pick numbers for x, and you have to think about what numbers, when you plug them in, will get you an answer. So that is another reason why domain is so important. You got to think about it in order to graph functions.